we're going to talk about angles today and really get some basic on angles and their relationships. Okay, so here are the types of angles. This should all be review. An acute angle is an angle that measures from 0 degrees to 90 degrees, not exactly 0 or 90. A right angle measures exactly 90 degrees. An obtuse angle is an angle that measure is between 90 degrees and 180 degrees. And a straight angle is a measure of 180 degrees. So you want to make sure not only you have those definitions, but you make sure you have a drawing as well that accompanies each of those types of angles. Okay, so here we have two angle relationships. Again, this should still be reviewed as well. We have complementary angles and supplementary angles. Complementary angles are two angles that have a sum of 90 degrees. And supplementary angles are two angles that have a sum of 180 degrees. A way to remember this is because 90 degrees is a right angle, it is the right thing to do to complement somebody. So complementary angle, right thing to do, two angles that make a right, or that add to be 90 degrees, which is a right angle. A common misconception is that complementary and supplementary angles have to be adjacent to each other, that is, they have to be right next to each other. That is not always the case. So if you see here we have two complementary angles. They are not right next to each other. They actually don't share any ray or any side. Those are still complementary angles because they add up to be 90. You can really see the difference with these two here. We see that this one is adjacent. They share this side here. And these are not adjacent. They don't share any side of their angles. So just because they're not next to each other, if they add up to be 180 degrees or 90 degrees, those two angles then have that relationship of complementary or supplementary. Okay, two more types of angle relationships that form when two lines intersect. So we see here that we have two lines here that are intersecting, and we have four angles here. We have vertical angles when this happens, or we have a linear pair. So vertical angles would be like 1 and 3. Those are vertical angles. Or 2 and 4. Those are also vertical angles. So angle 2 and angle 4. And then we also have angles 1 and angle 3. Those are vertical angles. Important thing about those, they are congruent. So they have the same measure. Okay? Linear pair are basically two angles that are adjacent and they share one of the sides of the angle. And when that happens, we have supplementary. So they can actually see that they form a line. So angles 2 and 3 would be considered linear. Angles 1 and 4 would be considered linear. However, if you see this, angles 2 and 1 are also linear. And then we have a last one, we could say angles 4 and angle 3. There are 4 linear pairs when we intersect two lines there. Okay, just like we had the segment addition postulate, we have an angle addition postulate. So here we have point M lies on the interior of angle OEG. And so then we can say that OEM plus MEG is equal to the measure of the entire angle OEG. Again, that's just like your segment addition postulate. Angle bisector, just like a bisector on a segment. An angle bisector, so here we have the ray AB, or point B lies exactly in between this angle here. So if ray AB is an angle bisector of angle CAD, then we can say that CAB is equal to the measure of BAD, sorry. And so an angle bisector cuts that angle in half. All right, let's just try a couple examples using some of the things that we saw. So here we have angle ABD and angle CBD form a linear pair. So we have ABD and CBD. We know they form a linear pair. And we also know that measure of angle ABD is 6x minus 12, so I'm just going to label that there. And I know CBD is x plus 31. I'm going to label that there. I'm looking for, it says right here, I want to find the measure of angle ABD. So that would be this angle right here. So what do we know about these angles? Well, I see that they're a linear pair. That means that those two angles are supplementary. So I can set up my equation, 6 minus 12 plus x plus 31. That's going to equal 180 because it's a linear pair, and linear pairs are supplementary. And then we use our algebra skills. So we have 7x, because 6x plus x equals 7x. And then negative 12 and 31 would make 19. So then, once we've combined our like terms, we're going to go ahead and use our subtraction property of equality to do this. And we're going to get 7x equals 161. And then we're going to divide by 7, so we get x equals 23. Go back to your problem. That's not what they wanted. They wanted the measure of angle ABD. So we have to then use our expression that equals ABD, and we're going to plug in our 23. Remember, if you don't do this and you say your answer is 23, your answer is wrong. So the measure of angle ABD is equal to 126. That is our answer. All right, let's look at this example. We have ray BD bisects angles ABC, and we have that ABD, it's already written there for us, is equal to that, and CBD is equal to 3.5 minus 3.4. So if that is an angle bisector, then we can say that 2.5x plus 8.6 is equal to 3.5x minus 3.4. Okay. Again, we're going to do our algebra here. So I'm going to subtract 2.5x from both sides. I get that there. Now I'm going to add 3.4 to both sides. So that's going to give me 12 equals x. So I know that x equals 12. And go back to your problem. We're looking for the measure of ABC. Well, if I notice ABC is actually the entire angle. So 12, I need to know just one of those angles. So I'm going to use 12, and I'm going to plug it into just one of them. Again, you have to make sure you read the problem, because if you don't read the problem and you write down an answer that they're not asking for, it's not going to be correct. So the measure of angle ABD is equal to 38.6, which is great, except for they want the total angle. Knowing that this is just 1/2 of the total angle, all we then have to do is double 38.6, and we get 77.2 degrees would be our angle ABC. Okay, in this diagram at the right, we have that lines AB and CD intersect, and we have the angles labeled, and we want to find AED. So they want us to find this angle here. If you notice, you have some X's and Y's in here. So when you go to set this up, you kind of have to know, write down everything you know. So the first thing that we know is 3x is equal to y minus 3x. We know that because these are vertical angles, and vertical angles are congruent to each other. We also have a linear pair. Now we have two ones that we can do. We can either do these two linear pairs, or we can always do this linear pair. Really, it doesn't matter. I'm going to stick with the brown one, the 3x plus 3x plus 2y equals 180. If you notice, you have two equations. You're trying to find y and x. If you remember back in Algebra 1, this is a linear system. We have two equations. We want to find both y and x. That's a linear system. So we're going to get going on this linear system here. The way I see it, I'm going to use substitution by first solving that one for y. So I'm going to go ahead, add 3x to both sides. We get 6x equals y. Now I'm going to use substitution and simply substitute this in for y into my second equation. So we have 3x plus 2 times 6x equals 180. So I combine so this is really 12x, so 3x plus 3x plus 12x is going to be 18x, which equals 180, divide by 18, so I know that x is 10. Great. If I'm looking for this angle, I need to use that angle and then make it congruent, or you could also use the fact that x equals 10, and we know that this angle is 3x, so 3 times 10 is 30, so if this angle is 30, these two are linear pairs, so 30 plus the measure of angle AED has to equal 180. Well, using my subtraction property of equality, I know that the measure of angle AED must be 150 degrees. And so that answers my question here. So everything you learn in Algebra 1 totally applies to geometry, especially the linear systems. And you're going to be working with some examples where you have to set up a linear system to be able to solve for x or y. In this case, we didn't need to solve for y because I'm looking at my answer. I could have solved for y and then used the vertical angle from here to here, but if I see these two angles right here are a linear pair and I only have an x here, well, then there's no need to find y. That's just more work than I need to do. So this is what we're going to be working on the next couple of blocks with our angle and angle relationships.